So just decided to start recording this little programming project I started where I've been trying to make this noughts and crosses game. I first want to make a thing that will allow me to play a game myself with noughts and crosses, or with myself I guess, through the command line. But then once I've got that working, I want to try and implement some form of a CPU to play the game against me. But anyway, so I started trying to code this, and as you can see from here, by the way, I'm using Racket, which it's a Lisp family language, which I find the most convenient thing to do these kind of small projects in, because it just has a really good IDE and stuff, and Dr. Racket is the IDE I'm using. So anyway, my first thought was that, thinking about the data structures I use in this program, I was thinking about the board, which is obviously in noughts and crosses just this 3x3 grid where a square can either be blank or have a nought in it or a cross in it. So I defined this contract, which is just a vector with 9 values in it, each of which is either blank, a nought, or a cross. And then I was thinking about how to compute the winner of the game from that board object. And I was just starting to write that down when I realized that not every board is like a valid state of the game, because there's only one winner, but a board could have 2 rows of 3 of the same symbol in it. Imagine, say, 3 noughts going across the top here, but you also have 3 crosses going across the bottom here. Obviously that would never happen in an actual game, but if we're just working directly with this board data structure, there's nothing to stop that being a legal value. So the way to solve that is to use a different data structure, and I realized that actually what a noughts and crosses game really is, you've got a game, well, it's like when you take a turn, you've got the previous state of the game, and then you add your nought or cross in a certain position that can be summarized by an x between 0 and 2 and a y between 0 and 2, given the coordinates of the square. And you can work out whether it's a nought and cross by just looking at whether it's an even or odd number of iterations from the starting game. Although, of course, you need a sort of dummy initial game. And once I started writing out that struct, I realized this is really just a linked list, and the game is really just a linked list of pairs of integers in the range 0 to 2. So I'm pretty sure now that that's the right data structure. So that was the moment I realized this might be something I should record, because I've been interested in recording myself programming for a while, but haven't been able to find a good problem to do that on. So now the next thing I'm going to do, we delete all this code, because now we have a better approach. So a game is just a list of these coordinates which represent a turn. Now, one thing we want to do, we want to know whose player it is. Well, we know, so each game object, you can think of it as will be a most recent term, which is summarized by the first element in the list. And we want to get the player from that, which, if the list is empty, it's going to be player 1. If it's a list of 1 element, it's going to be player 2. If it's a list of 3 elements, it's going to be player 1 again. So if it's a list of 2 elements, I should say. So basically, if a number of elements in the list is even, then it's player 1, and if it's odd, then it's player 2. So let's write that down. And instead of saying player 1 and player 2, I'm just going to call the players naught and cross. So cond even. Actually, don't know if even is a function in Racket. Looks like it is. So is odd. Yeah, odd is also a function. So if I wonder if Racket actually, well, let me write it down and then I'll tell you what I'm thinking. So I can do even length. Why have I written 4 there? What's the point of that? It's because I'm trying to think while trying to speak while writing at the same time. So if the length of the game is even, then it's player 1 who we'll say is naught. And if the length of the game is odd, then we'll say that the player is cross. And so what I was wondering was, when I do length game, is that actually going to walk through the list for each of these 2 invocations of the length function, or is Racket smart enough to notice that we've got the same expression here and cache the value? I don't know, but it doesn't really matter. Like for the length of, well, tic-tac, shouldn't call it tic-tac-toe, that's the evil American word. It's noughts and crosses. So, no, that's an interesting question. What is the maximal length of a noughts and crosses game? It obviously can't be longer than 9 because there's only 9 places to put the squares in. So anyway, that gives you a fairly small upper bound, which means there's really no need to worry about performance here. So we've got our player in the game. Now we should define a function to calculate the state of the board from a given turn. So define board game. Now, so I'm going to do a match on the game, and if the list is empty, then we're going to have the initial state of the board. So that's just a vector of blanks, and I'm not sure, pretty sure there must be a function to fill a vector with a constant of a specific value. Is it? I can't remember what it is though. So I might just go ahead and type everything out. Blank, blank, blank. Copy, paste. Simplest way to do it. And then the other thing we can match against is list. What do we call the coordinates? Coords, I guess. Oh, actually, so we're doing max here. That's the best way to do it. List context y priv. We'll call that. Make it a bit clearer. Call it priv game. So in this case, we've got our vector from the priv game, and all we want to do is update the square at the xy coordinate with the value from the current player. So how do you update a vector again? I need to look up Racket's vector because I don't remember any of these functions. So Racket vectors, make vector, that's the function we need. So make vector size value. So better way to write this, make vector 9 blank. For anyone not familiar with Lisp, when I put a quote in front of a word, it just means I'm using the identifier itself effectively as a kind of string rather than referring to a value, referring to a variable with that name. So we've got our vector of 9 blanks. Now we've got our board and we need to know how to update the vector. To have vector set probably like to do is there an immutable version of that? Vector. I mean, it does make more sense for this update operation to work mutably because that's somewhat more efficient. Yeah, let's just do it mutably for now. Vector set board priv game. Yeah, I've never done anything immutable with Racket before, so I'm not exactly sure how to work with it. So vector set vec pos value. So this is our vec, and we need a pos. So that's going to be our x coordinate. Now let's just think a minute. We've got this. The structure is like that. So easily integers corresponding to the coordinates. The x value, that is the value horizontally. So you're going to add on the x value and multiply the y value by 3. Oh, I've got that last line slightly wrong. So yeah, it would be plus star y3 x. Because, for example, in the case where y is 1 and x is 0, that's just going to give you 3. Y is 1 and x is 1, you add 1, you get 4. If y is 2, you get 6, and you can add 1 to get 7, and so on. And I should clarify that the coordinates are going from the top down in the y direction, which is kind of a standard in like games programming and stuff, even though in maths the convention is for the y-axis to go up. But we'll just stick with that convention because it's convenient. Well, I don't know if it's even any more convenient, but let's just go with it. And then the value, that's going to be the player of the current game. Not of the previous game, just the current game. Yeah. Yeah, because... that makes... No, there's a slight flaw in the logic of our player function then. Because if the list that comprises the game is completely empty, that means no one's actually took a turn yet. So when we're saying the player of this game is 0, what does that mean exactly? I guess it really should mean the player who's gonna make their turn next, because then that just means we have a player for every game state. So I'm gonna say that we should be taking the player of the priv game there. Now we're setting that vector, but that won't return the changed vector, will it? Actually, I don't know, it just says it return. Oh, because I'm looking at vector f. Yeah, that returns void. So I think match supports this syntax where we can just put a list of expressions and it will return the first one. So I don't feel comfortable about the mutability. So make vector So this will start with a blank, then we'll make vector. Because if I do vector set board proof game, that's not an L value that you can assign to, I think. Let's just make everything mutable. But how do you do the equivalent of vector immutable? So that just means you get all of those in that order. In fact, you don't even need a special function to make a vector with all these blanks because, well, I don't know. Can you do repeating a list? Racket list fill with value. I'm not sure how to do that. So I know what will definitely work. If we just do let v make vector 9, then we will can you copy a vector? Vector copy. So this takes destination vector to immutable vector. So we have our mutable vector here. Then we will So what we want is it should initially contain the values of board proof game, but it shouldn't actually be the same value. I still just don't really understand. Let's just make everything immutable. And the simplest way to do that is just, we know how to do that vector, immutable vector. Even though it seems a bit, verbose to use that function. That will work. Now, what we want to do, we'll build a new vector, so you can use that build vector function. That would be a quicker way to do it from the start. Build vector 5 and then just have a constant function. Build vector 9, lambda I blank. There we go. Finally, we're getting somewhere. Where is this? We don't need that. Alright. So now we're going to do build vector again. It's being 9. And then in our lambda, which generates the values, if equals I, the integer form of the coordinate we've got, then we're going to put in the player value. Otherwise, we take it from the previous game, which we can do by just using vector ref board proof game plus star y3x, and we should really factor out that's star y3x because it just makes things clearer that way. I always get it's just a question of style, but I feel like the right thing to do is put the square bracket immediately before the variable name. So let's say that I is plus star y3x. It makes more sense to have it that way round, because then it's more alphabetical. Well, let's call this j. If equals ij, play a proof game. Otherwise, vector f board proof game j. There we go. That makes sense. And the indication is messed up there. Now that is a correct function, I think, although there is still a slight improvement we can make because we want this to be a legal move. So basically that just means what's in this value already has to not be blank. So we'll put this value up here. And we'll need to use let star there because we're using the value of I to define v. Start bracket. It would be a nightmare to do anything in this without the editor that shows you the matching brackets. I've got I and v. Is there a better name for v? Not really. So if v blank, play a proof game, otherwise we're going to raise an error. And this is a convention for raising errors in Racket. You supply this function called raisEargumentsError, the symbol for the function, which should just be board, not game. Then you do a description of the error, illegal move, and just pass in, send out some relevant values. So all we need to show is the game. So now I think that's all correct, but this is a sufficiently complex function that we should test it. So Racket has a really nice approach to testing where you can have a submodule in your module called test, and you can just interleave between the top level code and the code within this module using this module plus command. So we'll require a unit testing library at the top, and then we'll just add our unit tests by further interleavings of this submodule. We're going to check equal that nought board. Okay, so we want, this is going to be just player 1 putting nought in the top left corner, and that's going to look like vector nought blank 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 blank. See if that works. No matching clause for a list of pairs. Now why is that? That's the right syntax for a list of pairs, isn't it? So define x nought. Oh, it's because we should be using cons here, because that's the tail of the list. I think doing dot would also work. Well, this is simpler. Yeah, so now our test passes. I'm not going to do any more testing. I'm reasonably confident in that. So the next question, we've basically got the turn-taking mechanism in place, kind of. Now we need to be able to check who's won a game. So, define win a game. And this will just look at the last 3 entries in the list, because no, it will have to look at, well, we can define this as a function on the board, but you'll know that since it's being constructed from a game, that it will have certain properties. So a player wins noughts and crosses when they get 3 along a line. That can be diagonal, horizontal, vertical. So you've got the 3 horizontal lines, the 3 vertical lines, and you've also got 2 diagonals. So in total, there's just 8 possible ways of winning. And we can basically just test each one of those individually. So before we define winner, we'll define the lines in the board, which can just be a constant. So that would be along the top row. Then this would be along the middle row horizontally. This would be along the bottom row horizontally. Now for the vertical ones, we'd have along the left row vertically, so that would be 1.0, 2.0. Oh, this needs to be a list. So let's put an extra bracket there. Nought dot 1, 1.1, 2.1. This is the middle row vertically. This is the right row vertically. And finally the 2 diagonals. Also, the order of these are really sets, not lists, I guess. But we can still have them as sets, as lists in our data, but really they are functionally sets. So what would be the top right corner? That is the x is still 0, but the y is 2. And then the bottom left, no, the x is 2 and the y is 0. Then in the bottom left, the x is 0 and the y is 2. So then, to get the winner of the game, we want to look through all of those lines. And we just want to know, we should have a helper function for getting the the value on a board. So we are still kind of doing things in terms of board rather than in the actual game itself. So maybe there's a better way to do this, or maybe it was right to use boards after all. Board value board. Obviously we need to also hand in the coordinates, and it will make more sense to do it as a pair. So that would be extract the x and y from the coordinates. Oh yeah, that works. Then with the context y, we just do vector f board plus x star y3. There we go. And we can actually use that up here rather than using, well, it still makes sense to have I and j here. Yeah, so let's just leave that as is, it doesn't really matter. So finally, to get the winner of the game, I'm going to look through all of these lines, and each of those lines is a list of coordinates. For each of those coordinates we get the board value. If any line is such that each coordinate goes to the same board value and it's not blank, then that player whose value it is the winner. So we need to filter out all of the lines satisfying that condition. Filter lambda line you can just do this to extract the values. List XYZ line, because we know there's only 3. If you want and xy, does that 3-way equality work in Racket? No, it doesn't, so we'll just have to do this like that. Just put that first because I think it'll be encountered more often. Alright, so that's our filter. And there's going to be 2 possible outcomes from this filter. One possible outcome is that there are no lines satisfying this condition. In that case, nobody's won. Otherwise, we've got a list containing that line, and we can say that the winner is a common value on each of them. So let's put that in a let to make it clearer. Null tests whether a wood list is empty, so if null winning lines false means there's no winner, and otherwise, or better to just use a symbol for that, let's say no winner. Nah, I'll stick with false because there's convenient things you can do with and and or when you have false. Then you do filter, no, what am I doing? So you want to extract the common value of the line, but since you know they're all the same and you know the line has exactly 3 items, all you need to do is car winning lines. The first car gets you the first winning line, and you know there's only one. Well, there could be two, but only if there's an invalid game state. And then you extract the common element of that line by getting its first element using the second car. So that gets us the winner. Now let's do a little test for this. Module plus test. So what does a winning game look like? Check ec. I don't know if the test just actually has a check ec. So basically ec is just, it works for symbols and not much else. Mostly you use equal in Racket. So you want a game, first move from naught will be 0.0, and Cross is going to be really dumb. He'll just put 1 down in 2.0, then 0 puts 1 back up in 0.1. Cross is following up by just going on 2.1, but then 0 puts 1 in 0.2, and now he's 1. So this should say that the winner is 0. Let's see. Alright, we've got a contract violation. That is because the board is a vector. So, is there a vector filter function? Yes, there is. Let's put that lambda down one line so the indentation isn't quite so pushed to the back. Oh yeah, we need to save this at some point, so I'm gonna put that in. Let's make a generic Racket directory. This doesn't really deserve its own folder. Let's run and see if the test works. No matching clause for north. Interesting. So one of our lines is naught. Got the board of the game. Oh, because the board is actually the set of values. So what's going on here? Winning lines, board game. Oh, we just haven't gotten the lines out of the board. But it's, oh no. Yeah. Yeah, so this is what we want to do is we're filtering out the lines. For each line, we get x, y, z, those are the coordinates. But what we need to do is match these coordinates to the values. So, we need to do another let. There's loads of repetition going on in here. So, solve that with another let. Let's store board game. X value, board, X, Y. So it's a bit misleading to call them X, Y, and Z. Let's just call them first, second, third, because X, Y, and Z makes you think of coordinates. And we'll just have value 1, value 2, value 3. In fact, what we really want to do is just map over this line. Map query board value board. Yeah, that's the straightforward. Well, I don't know about straightforward, but it's more pleasing to the functional programming mindset to do it this way. So now we've got our first, second, third, and they're actually values and not thingy coordinates. And then our condition will work. We test whether the first is blank, first is equal to second, second is equal to third. There we go. Does this test pass? Alright. Expected vector given list. That's because we're filtering over a vector and lines now actually is a list. However, still an error. Now we're using vector f on a procedure because we haven't defined the board, but we can just do board game. Alright, does that work? Failure, because it is not returning a symbol. Of course, it's returning the coordinate of that symbol. We need to use board value again on that output, but then so again, to avoid repetition, let board game go back up the winning lines. Board value board. Yeah, now that works, I think. Yes. So now we have a function that will determine the winner, and I have only just done one test case here. Really I should put in more, but it's more interesting to work on the actual logic. So how do we start playing against the computer? Well, so I don't actually know much about doing input and output in Racket. Let's look it up. Racket get command line input. What is this blogger saying? This is about parsing command line options. How about try Racket read input? How to read input as a string in Racket. Question is a bit vague, but it looks like he's using read line. That's neat. Alright, so read line works. So each stage will show the initial state of the board. So define present game. This is just going to be a function with no arguments. We'll define an iterator function. I think we'll probably need something like that. Or maybe not. Oh yeah, we need to pass through the game. So we're going to define this, it's a function. This is basically how you do the equivalent of loops in Racket with tail recursive functions. So we start with the empty game, and the first thing we do when we have any game state, we're going to display that game state. Oh, display game. Now we need to define that function. That should be fairly simple. What we just want to do is print out a visual representation of the board. Define display game. We can even just make this act on the board. Display board game. So we want to display a string. In fact, it's even more. It's better to have a board to string function, and then we'll call display here. Give the caller choice about what exactly to do with a string. The string. Why couldn't I say string then? I don't know. I mean, it does have a triple consonant cluster, which speakers of many languages would find difficult. But anyway, so it's just going to be a string append of 3 strings. First string is, so let's just define a little helper. I always get that the wrong way around. It's hash, then backslash, and this is how you do a character in Racket. It's a slightly obscure syntax. I wonder if that actually works. Yeah, that gives us a space. So that would be the really tedious way to do it. But the better thing to do is map lambda coord board value string board value coord, and then we'll present the list of coords here. I feel like I keep getting confused with these x and y coordinates, so that's going to be going vertically, isn't it? I mean, yeah, we want the horizontal ones first. Oh yeah, and I just realised there's this string join function in Racket, which will automatically put a space separator between your strings. So, for example, string join AB, we need to put in a list. List AB, AB. Instead of string append, we'll use string join here. And I think you can add in the separator as an optional argument. That was passed as a new line, wasn't it? I think it's just because it's not displayed. Yeah, that's all working as expected. So string join map lambda coord. We want this to be a row. String join second row. Again, we are repeating ourselves here, so I think you could just put this in another map, but I'm just gonna not do that for now. I definitely feel like I've got the roles of x and y mixed up somewhere in this program, but we'll see that when it comes to testing. Oh yeah, we need to make that a list. And put in a new line. So that should work for displaying the board. Now we'll comment that out for now using the handy Racket S expression comment syntax and check that display board. We need to rename that to board to string. Check equal board string. Just go with in fact, I don't want the space to be blank because it's not visible. Let's have blank just be a hyphen. So board to string board of the initial game. That should look like 3 hyphens, new line, 3 more hyphens, new line. Can you actually I feel like it's best to just keep it really explicit since this is a test. So let's test whether that works. Forgot the question mark. Board value, arity mismatch. Board value, that doesn't take a coordinate. Oh, we need to pass in the board. Yeah, we didn't actually use the parameter anywhere in that function. String join contract violation. Expect the list of string while it's being given is a list of characters. So, yeah, Let's just make that return characters and not strings. It makes things easier. Alright, now it's working. So, when we present the game, the first thing we do is display the current state of the board. And we'll put a new line after it. Then we display whose turn it is to make the next move. So we want to display format, and we can just use our board to string function here. A is for a format placeholder, so board value string play a game. That's probably the best way to express it. Display that, and that will also be on its new line. Then we read the line, so what should we call it? Let move read line, and there's you have to do a kind of parsing here, I guess, before you can move on. Instead of worrying about that for now, let's just work with the function as it currently is. What this should do is it should show the initial board, and then it should show that the next move is for naught. Let's see if it happens. Yep, that's nice. So, player enters in the move, that will just be a number between 0 and 2 and another number between 0 and 2. Does Racket have a string split function? It does. So we'll just split on split white space as normal. Pattern matching is often quite useful. It's one of the things I like about Racket. String split, string, you can just pass in the plain string. You don't really need the let, but I'll just keep it in for 2, because we could just have a move down in there. Match let, move read line. So we've extracted our move, and that means the next game will just be so then we just present present game iter for the resulting game, which would be... Oh, we didn't put in something to add a player to the game, to like add a move to the game, did we? Oh yeah, because that's just the data structure itself. So all we have to do is const that move to the game. Alright, now I think that should actually be working. Wait. Move isn't working because we weren't using match let star. Next move, O. I want to go in the top left corner. Now we've got our O there. Next move is for X and he's going to go in the middle. Alright, now O is going to go in the top right, so it's not the greatest interface for this. Well, that would be 2, X is 0, and Y is 2, 0, 2. It's putting it down there. So we have got some of the X and Y coordinates mixed up, I think. But anyway, now I haven't put in the win condition. But that should be pretty simple to add as well. So we can add the new game into our match let expression here. If match win a game, no, just if win a game will work fine. Alright, I think that's now the win condition. But what if we do an illegal move? Yeah, so the error does get thrown, which is good, but we should really handle that. But for now I just want to test that the win condition is working. So O goes in 0, 0. X, we will say, goes in 0, 1. Then O goes in 1, 0. X goes in 0, 2. Then we go in 2, 0, and now... Alright, so the win condition hasn't worked because O should now be a winner. What is going on there? Oh! So now there's a winner? Oh, because we're not looking at the winner of the new game, that makes sense. But there's an error in our handling of a win condition. So display line is expecting an output port because we're not calling format. There we go. No, no. Not 1. 1 not. 2 not. Oh, I've inadvertently made the game more complicated. Okay, so O is going to go to 1, 1 now. Now X is going to be dumb and go in, what would it be? The X should be 2 here and the Y should be 0, but It's actually the wrong way around, so X should go there. Yeah, now Vx should be 2 and Y should be 1, but the other way around. Yep. Although we haven't shown the board with O as the winner, and we should. That can be rectified easily. Begin display line. We want to show the board before that. Oh yeah, and we can put new game here. Alright, that's a fairly functional noughts and crosses game, and I know I said I wanted to do the AI, but maybe I'll do it some other time because I've been recording for a little while here. I will stop recording for now. I think that was a pretty good programming session to be recording.